All right, let's talk about counting. Now, one of the hardest things about counting is determining which method to use. So right now we're talking about this basic counting principle. We're also going to talk about some other methods a little bit later on in this module. We'll talk about combinations and permutations. So as we look at this, I want you to really focus on what leads us to want to use this basic counting principle. So in this problem here, we've had this license plate that's going to be in the form of 3 letters followed by 3 numbers. So like MTH314 would be one example that would work. And we want to look at how many different license plates can be made using this pattern. And we're allowed to have letters and numbers that are reused. So you could theoretically have MMM333, and that's perfectly fine. So what leads me to believe that this is going to be a good counting principle type of problem is the fact that every choice I have to make is completely independent, and I can count how many ways I can make that choice. So in this example here, our license plate is going to have a letter, a letter, a letter, followed by a number, a number, a number. So I'm going to go ahead and put A to remember that these are letters, and these are going to be numbers here. And for each of these, I know how many choices I have for each individual digit here. So for the very first one, there are 26 options for a letter. And then if we move on to the second one, there's still 26 options. Now, if we weren't allowing repeats, this number would be 25. Now, again, the third one, since we are allowing repeats, is going to stay 26. And then again, if we were not allowing repeats, we'd be down to 24 options at that point because we've already accounted for 2 letters. Now, when it comes to the numbers, now, you got to be careful here because your brain's going to be a little deceptive to you. You might think and say, hey, I could get up to 9 here. 9 is the biggest number I could allow. But there's actually 10 different digits because of 0. So if we were to actually count out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can see that there's actually 10 options there. And personally, an easier way to see this is to realize that 1 through 9 are 9 of them, and you can kind of think about 0 as the 10th digit then. So in this case, we're going to have 10, 10, 10 there. And then the counting principle tells us that if we want the total number of license plates going to be made in this way, we're going to multiply each of these together. And so off screen right now, I'm grabbing a calculator because it's not really a tricky calculation that you need to see me produce. But I'm going to put in 26 times 26 times 26 times 10 times 10 times 10. And when I do that, I get this really big number, 17576, followed by 3 zeros. So if I start putting my commas in, now I can see that it's 17,576,000. Expect to get really big numbers as we're starting to work through these modules because the whole idea of learning these counting methods is that we want to be able to use these strategies, these combinatorial strategies, in order to count these things that there's a lot of possibilities for. If there's only 10 to 50 possibilities, we could just count them. We'd be like 1, 2, 3, 4, 5, But we're going to be using these strategies because they're larger, more complicated numbers. Now let's look at this second example where it's a little bit trickier. So we've got Stu Dent here, has 15 different math books, 5 different science books, and 14 different engineering books. And we want to find the number of ways to pick 2 books with different subjects. Now, if this problem had said 3 books, this problem would be really easy because we would just say, all right, so we have math, science, and engineering, and it would be 15, 5, and 14, and we'd multiply those together, and that would be that. But this problem is a little bit trickier because of the fact that we're only wanting to pick 2 books. So let's talk about some strategies here. What I would do in this case is I would first of all determine the possible ways that we could pick 2 books that have different subjects. And by that then, I mean, let's look at the fact that I could have a math and a science. Or I could have a math and an engineering. Now, the order these come in don't matter, so we're not going to talk about science and then math as a whole separate option. So that's the only ways that we can have a math book, is either having a math and a science or also math and an engineering. So then the other possibility is, what if we don't have a math book at all? What if we have a science and an engineering? So these are our three possibilities to pick out two books with different subjects. But within those, we have a lot of different options. So for the math, there's 15 different textbooks that are math. For science, there's 5. And for engineering, there's 14. So if we use our accounting principle here, then it looks like the number of ways that we can have a math and a science, if we multiply 15 and 5 together, we get 75. Or we could have a math and an engineering, and so 15 times 14 would get us 210. Or we could have a science and an engineering, which gets us 70. Then we got to look at those three numbers. Now, these aren't independent in the sense that we're going to multiply these together, because we're not going to have math, science, and math and engineering. These are ors. So there's 75 ways of doing math and science, 210 ways of math and engineering, 70 ways of science and engineering. So if I want the total number of ways, I'm going to add those up. So if I add 75, 210, and 70 together, I'm going to get 355. There are 355 different options of choosing two books with two different subjects.